my name is Annika Pint, and I'm joined by my good friend and first LEGO League Challenge coach and coder extraordinaire, Yannick you. And we're here today to talk to you about building and coding LEGO robots using the Virtual Robotics Toolkit. You may be wondering, what is the Virtual Robotics Toolkit? Well, it's a robotics simulator that's designed for use with LEGO Mindstorms, and it allows users to design, build, program, and test virtual robots without the need for physical equipment or space for testing. And some of the benefits to using the Virtual Robotics Toolkit include use in classrooms that have few or no LEGO Mindstorms EV3 core sets. If you're coaching a first LEGO League Challenge team, you can use this for training and skill development. You can even compete in or host virtual competitions. And this is a great way to engage youth in coding and robotics. And as I mentioned before, without the need for the physical equipment or the challenge mats. So in order to use this tool, you need obviously the Virtual Robotics Toolkit, but there are also some companion software that are shown here that you will also need in order to build virtual robots, import them into the Virtual Robotics Toolkit, and then also program them to move within the virtual environments available in the Virtual Robotics Toolkit. And all of these software are actually available free, and you can download them at the website shown here. And there is also an activation code that you'll be given that you can use to activate the Virtual Robotics Toolkit, but the other software that I mentioned are available free as well, and links to those installation files can be found on this website. Within the Virtual Robotics Toolkit, as we'll see in a moment, there are a whole variety of different environments and different challenges that users can complete to practice their coding skills. And we'll take a look at some of those different environments throughout this session. And we'll also take a look at some of the different ways that you can actually move your robot within those virtual environments. So the three main ways that we'll take a look at include using the keyboard, using LEGO Mindstorms EV3 lab software, and also using MakeCode. I'll go back into the Virtual Robotics Toolkit and open a new project. I wanted to show you that there are a variety of different environments from which to choose. And so we'll go back into the cleanup challenge. And you'll notice that when I do so, there's a display here of the LEGO Mindstorms EV3 intelligent brick that looks a whole lot like the physical brick, and it actually works in the same way. So this brick is called the EV3 Educator. When I go back into the LEGO Mindstorms EV3 software, I notice that the same name is down here and that I can connect via Bluetooth, Wi-Fi. And then I can download this program, which is called DriveTurn, onto the EV3 Educator vehicle model. Okay. So once we hear that sound, I'm going to go back into the Virtual Robotics Toolkit and use the brick buttons to navigate through the file menu to find the program that I'd like to try. So let's run this program and see how it works. Okay, not so bad. You can see that there are a few parts of the tower left, and although my robot didn't fall off the platform, which is a good thing, there's no other additional steps in the program that allow the robot to finish clearing off the platform. So I'd like to show you a few other programs that would maybe allow me to clear the tower from the platform. So I'm back in my EV3 software and wanted to show you another program that I could use to try and accomplish this task. In this program, it makes use of the color sensor on the robot to detect the white perimeter of the platform. And so what the robot is programmed to do is to drive forward if the light sensor detects that the robot is over the black surface or the interior surface of the platform. And then when it gets to the border where it sees a white line, the robot is programmed to back up and then turn and then repeat that in a slightly different direction. So again, I can download this to my brick. When you hear that sound, you'll know that it's happened. When I go back to the Virtual Robotics Toolkit, I can again use the brick buttons to find that program. And this one's called Boundary. And let's see how the robot performs in this case. So as you saw, it drove towards the perimeter. It detected the white line, backs up once it does so, turns a little bit, and keeps doing so. It's still a little bit random because it's not really detecting the location of the blocks themselves, but instead the border of the platform. So it's really just by chance if along its path it happens to come in contact with any of those blocks, which it doesn't look like it's going to do anytime soon. But I think you get the point. I'll stop this program and we'll go back and look at one additional program that might work well. The way that this program works is that it makes use of the ultrasonic sensor to detect obstacles in the path of the robot. And in this program, the robot starts by turning until it detects something within 100 centimeters of the ultrasonic sensor. And when it does, it will drive forward, and then it will use some of the components of the previous program to determine when it reaches the perimeter of the platform. And once it does, it will again back up and start the sweep again, looking for other obstacles to push off the platform. So let's download that. Head back to the VRT to try this program and see how it works. So you can see the, beams of the ultrasonic sensor shooting out from the front of the robot, and when it detects some obstacles, it drives towards them and continues until it reaches the perimeter of the platform. I guess check to see if it missed anything, which it seems to be doing now. Despite there still being obstacles on the platform, it doesn't seem as though they're being detected by the ultrasonic sensor. So might need to modify the design of the robot or modify the program slightly so that it continues to clear the tower. But again, I think you probably get the point there. I'll stop the simulation here and would like to show you next how you can program the robot not only using the LEGO Mindstorms EV3 software, but also using make code for EV3. Okay, so to program the robot using make code, I need to go into what's called simple view for the virtual robotics toolkit, and then click on function F8. And when I do so, it brings me to this split screen that you see here. And I'd like to check out my projects. And I notice here that there is a file called Kickoff Conference. That's the program that I'd like to show you today. So I'll open that one. And just wanted to show you quickly that the make code is similar to Scratch for those of you that might have used that programming software before. And in Scratch and in make code, there are some different palettes or menus of blocks from which to choose. And you can, again, create very complex scripts using all of the different blocks that are available in make code. For today's purposes, we'll just do a simple program similar to one of the ones that was created in the LEGO Mindstorms EV3 Lab software, in which the robot drove forward for 1.5 wheel rotations, turned towards the tower, and then drove forward another 5 wheel rotations until it gets to the edge of the platform. So to run this program, I'm going to click on play here. You can see in the top part of the screen that the robot kind of missed its mark there, and that it's hanging out there near the end of the platform. So I noticed that it turned a bit too much. So I'm going to try and modify that a little bit. Let's try 0.4, and let's try it again. A little bit better. So you can see that it's quick and easy to modify the programs and test them again, which is really great for testing out different types of robot designs and how they're going to perform under different conditions or with different programs. Okay, so we've taken a look at some of the different ways that you can move the robot in the Virtual Robotics Toolkit. And I wanted to mention just briefly, although Yannick again is going to show you how to do this in much more detail, that you can design and build your own robots using a couple of different types of software, one of which is the LEGO Digital Designer, and the other is Studio 2.0 by Bricklinks. And it's great because you have a whole virtual library of LEGO parts. You can also download and modify existing models instead of having to start from scratch. And then once you've done so, you can import those designs into the VRT, as Yannick will show you in just a couple of minutes. And you can use those to complete the challenges maybe better than the pre-built robots that come with the software. The other cool thing about that is that you can also, once you've created a robot, you can generate and share the parts list and also the building instructions, so that if someone else wants to build it virtually or use the physical model to rebuild your robot, they can do so using your instructions. The other cool thing is that you can participate in virtual competitions at this website, www.robotvirtualgames.com. And I'll just show you quickly what that website looks like. When you visit www.robotvirtualgames.com, you'll be taken to a page that looks like this. And if you click on competitions, you can see that there are a whole bunch of different competitions for different levels. And if you notice that in the different challenges, some of them are open to everyone. and some of them require registration. So you can check out those different challenges if there are ones in which you'd like to compete. In addition to competing in different challenges, you can also take a course or give your students a course on how to actually use the virtual robotics toolkit in conjunction with the Lego Mindstorms EV3 software. So there's a great course created by Robots Got Talents called STEM Hero, and you can see that it's broken down into 7 different lessons. This is an example of what to expect during session 2. And in order to access the course, there's also a really good user guide that you can access, again, by signing up for the individual course at the website that's shown here. So hoping that gives you a little bit of an introduction as to how you can use the Virtual Robotics Toolkit to program and test robots. We'll be talking a bit more about some of the different resources that I mentioned and what you can do if you'd like to learn more. But before we do that, I'd like to pass it off again to my esteemed colleague, Yannick to tell you a little bit more about how to import robots into the VRT and also how to program your virtual robot to follow a line and then test out that program. So over to you, Yannick.
Hello everyone. Today I'd like to do a quick demo to show how to import your own robot design into Virtual Robotic Toolkit for testing. So first thing first, you need to have your own robot design. What I'm going to do today, what I'm going to use today is called the Lego Digital Designer. There are different tools you can use for robot design. If in case you have never used the Lego Digital Designer, I actually recommend to use something else called the Studio 2.0. The reason being, this tool is being actively supported on both Windows and Mac. While Lego Digital Designer technically it's a discontinued product, it still works on Windows. However, it no longer supports the latest Mac. The result is more or less the same, I would say. Both of them are fairly easy to use, and both can produce something, can be imported into Virtual Robotic Toolkit. So I'm going to quickly, well, this is not a great robot design to begin with. It's the one I put together quickly. Just want to figure out how to use Lego Digital Designer and along with the Virtual Robotic Toolkit. So there are many flaws with this robot. It is only for demonstration purpose. So what it does is have 2 wheels and 2 front large motor to drive attachment, 2 light sensors, 1 gyro sensor in the middle. So what I'm going to do, I will skip the part for how to use Lego Digital Designer because it really is quite straightforward. So what I'm going to focus on is how to export and then import it into Virtual Robotic Toolkit. Here to export, choose this one, export the model, and under here you need to choose what type of file to use. We need to use LDRAW file to be supported by Virtual Robotic Toolkit. The file already exists, so I'm going to override that. At the end, you will end up getting this file. You can, if you have a LD View app installed, you can actually open this file to see how it looks like. It's still the same robot, it's just in a different format. You can actually pretty cool. You can change the lighting. You can rotate this robot if you like this to see, and zoom in, zoom out, just to see all the details of your own design. But we're not going to use this tool too much. It's only for viewing your exported robot. What we're going to do next is to launch Virtual Robotic Toolkit to import this model into VRT. So keep that in mind. That this tool is a bit of a, I'll skip the update part. It's a bit of a resource demanding. So I'm going to show you what I mean very quickly. I do recommend for importing a robot, actually it's not a recommendation. To import a robot, you need to turn on the advanced mode. To do that, just simply press F12. So that's going to turn on this menu. So what we're going to do is first to create a new project. Actually, we're going to create a new project. Choose enter first Lego league, and I'm going to use the one of the older map, this one, into the orbit. It already exists, so I'm going to just overwrite it, start from scratch. So yeah, here's what I mean. What I'm using right now is a Core i7 with SSD, 16 gigabytes of memory, but it's still, I would not say it's very fast. It's quite resource demanding, really, for to render the virtual environment, the robot, and the mat, everything. So let's give it a bit of time to get it loaded. Meanwhile, when you launch Virtual Robotic Toolkit, it's going to launch your EV3 LabVIEW-based EV3 app automatically. I'm not actually quite sure whether it supports the latest version, the EV3 Classroom, the Scratch-based version of it. But I assume so, but I haven't really tried it myself. Because this year we are using something totally different. For my team, we're using MicroPython instead. So we haven't tried this tool lately. So let it load, and this is the simple program I put together only for the demo purpose. What it does is really just a very simple two-step line following to show what you can do with the Virtual Robotic Toolkit actually to test your line following algorithm. This is a very simple one, but you can try more advanced algorithm like PID line following if you want. Again, this is only for demonstration purpose, so I try to keep it as simple as possible. Still loading. Let's give it, I think we're almost there. Should maybe another few seconds or so. The good thing is, typically you only need to load it once, then just leave it open to work on your robot design, work on your programming. You don't need to do it all the time, many times a day. All right, so finally. So here is the default mat with the default robot. It's already there. You can the tool you can pan it. You can zoom it in out. Yeah. All right. So what the first thing you need to do before you import your robot is you probably can tell you already have a robot on the mat. It's not going to be very helpful. So the first thing you want to do is to click this one to choose your robot. Oh, here we go. Sorry. First one, right click onto it and click delete, because you want to use your own robot. You don't want to leave the default robot on the mat anymore. Now to import your own robot, click this one, import robot, then choose the folder you're going to use. Here I have this model just exported from Lego Digital Designer. The importing process also a bit of time consuming, many steps, so I will quickly walk through that. The entire process for the parts are not going to be very necessary for what we need to do today. I will just quickly talk through it, but not going to actually do those parts because they're quite time consuming to finish the entire importing process. What I like to focus on really to, once you have everything imported, how to hook it up with your EV3 program and how to troubleshoot, the debug, and the test your program and your robot and attachment, for a matter of fact, if you like to. for the robot, well, this one doesn't have any attachment, but for the other map I'm going to use shortly does come with attachment, but it was more like half done, only for demonstration purpose. But technically, you can build a robot along with attachment and to actually finish some real first Lego League mission. Importing also, yeah, I think I mentioned that already. Importing is this tool itself is quite resource demanding, so importing also takes some time. We're almost there. Then after the initial importing phase is done, we will need to take quite a few steps because to finish the entire process, because the tool it's a generic tool. You need to, but you still need to tell the tool many things to let this tool, the environment, understand your robot better. For example, which motor is connected to what port. I'm going to walk through that. Which sensor connect to what port, the location, position of that motor or sensor, because all these things matters when you come to simulating your robot, your virtual robot on a virtual mat with a virtual missions. So that this all matter to make sure you get them right. Otherwise, you might not get the result you need. Yeah, almost done. Well, we're waiting. Maybe we'll come back to this short program again. As I said, it's for line following. So it's really, maybe maximize it for now. It's really, it for most part, it just turn the robot around and go to certain distance. Let me see. I haven't looked into this for a while. Using gyro sensor and also to using the gyro sensor to turn like 180 degree, then start moving forward, find a line, trying to follow it. That's basically what it does. It is okay. Now it's done. Although it's very simple, but it's essentially touches all the parts like on the robot. That's why it's used for the demo purpose. So here you can name the different structure of the robot. For this, it's the main chassis. You can also name this is the left wheel. You can actually just rotate it to see better. Left wheel, the right wheel. This one, yeah. This one actually the right attachment motor. It's not entirely necessary for what we need to do today, so just I'm going to just skip it for now. This part is rather important. You need to name the sensors and the motors. The reason being, if you don't name them, it's very hard to tell which one is which when you need to choose a port. And you need to map them to the right port. Otherwise, your program would get confused, because it would be very difficult to control the robot if they're not connected to the right port. So for this one, to take a look, you can tell it's the right color sensor. I just simply put it right there, so I know which one it is. There's only one gyro sensor, so I can skip it, and the other one, the left one. The motors, we are not going to use. Oh, actually, you know what? Let me name all of them. This one, the left attachment motor. This one is the right attachment. It's the right wheel. The left wheel. Here, when you choose the port, you will tell why. You will see why it's important to put in the right name. Otherwise, you have like a multiple motor. They all have the same name. It's very hard to tell which one is the one that's connected to the port A, B, C, D. What you need to do, really, what you want to do is to match the motor sensor to the actual port you use on your real robot, so that you can simulate your robot and you can essentially use the same code for that robot in the virtual robotic toolkit. Otherwise, you will need to modify the code to work on to make it work on the real robot. For now, because this is only for importing, I have a different project with the imported with everything positioned for demo purpose. So I'm going to just skip through this because it's not going to make a huge difference here. When you import your own robot, make sure you choose the right port. It's really just for saving time. I can't go through the entire process again. It's take much longer. I don't have any gears connected here. Otherwise, you can choose which one, whether it's active or passive. So I'm going to skip this one as well. This step. The next one, this is probably the most time-consuming part. So you need to choose the front of the robot. The tool doesn't necessarily know which part you are using as front. So I will tell the tool, this part, this is front, that's the back. Then for each motor, what you can do is you can create some keystroke mapping to control the control each motor. So what you can do is to map, like say, like up, down, left, right, to control each individual motor, so that you can control your robot move, turn around, move forward, backward on the Mac. You can also use the keys to control your attachment motor, so that you can drive your attachment. But the problem with that is for each motor you need to map 4 keys. For certain cases you might need to do more, and each key would be like defines the key up and down, press, release, and RPM for each motor. So it's very time consuming because we're not going to use that feature today, so I'm going to skip it as well. Otherwise, this would probably easily take like 15 minutes. So I'm going to skip it. Finishing up the model will take some time again. It's as I said, it's a bit resource demanding. To let it finish, this one is much quicker than launching the starting a new project, as I recall. So right now, it's really just importing everything into Virtual Robotic Toolkit to get everything sorted out and allow you to control your robot moving forward. Well, while we're waiting, I think for year 2020, some tool like this will be very valuable because without the ongoing pandemic, when it's much safer, easier for the team to meet, everyone would have a chance to play with the robot, to spend more time with the rest of the team and work on the robot together. Now, social distancing is very important to keep everyone safe. Because of that, unless everyone has an individual robot, everyone has an individual mat, which is not really that practical, considering how much it costs and how much space it takes. Then something like this would be very helpful to allow each one, without the physical access to the robot, but still be able to test your robot on the real mat. It's a bit of an unfortunate that we have the mat for the previous years, including last year, but we don't have the mat in this year in Virtual Robotic Toolkit. But you still can import the robot design by using either Lego Digital Designer or Studio 2.0, and to import your robot and try your program on a real table like this to see how everything works or doesn't work, then make adjustments accordingly. All right, so now we're able to pan it, zoom in, rotate, and this is your robot. You can just move it up and down, left and right to position on the mat, and to check basically to see how everything looks. So as I mentioned, I have a separate project because to make it work with your, I'm going to load it now because it takes some time. To make this work with your code, the robot need to be well positioned. I don't really have it. Here we go. So this is where it's located. I don't have this robot well positioned right now, so I might need to do quite a bit of tweaking to make it work with this demo code. So that's why I have a pre-recorded, pre-created project with everything well positioned, so I can directly run to see how everything goes on the map with the already imported robot, and to show how the line following works in the virtual environment. Mainly, I can get it work step by step, but this take a quite a bit of time. So I will just skip that. Instead, I'm going to load a different project. And this project happens to be City Shaper. It's the mat from last year. I think some of you, maybe many of the viewers participated last year. You will be very familiar with this map. Again, like when everyone had access to the physical robot and the mat, some tool like this will be good to have, but it won't be very critical. When everyone's remote, when not everyone has access to the robot or mat, something like this will be highly valuable, for my opinion, to be able to continue on with your robot design, continue on with your programming and attachment design with minimum access to the robot. We don't have the access to this year's mat. That's a bit of unfortunate. However, just by practicing on the mat from last year or the years before would still be very highly valuable. Yeah, I would not say it's very fast to load the project. Um, I mentioned that this is a Core i7, but it's a laptop. I assume with a desktop Core i7, likely will be faster than this. I would say it's still manageable, not too bad, considering what you can get out of this tool. Oh, here we go. All right, so this is a robot, and this one actually has an attachment bolted onto it. It's not supposed to be sticking out like this. It's kind of against the road, but this is only for testing purpose, and because the robot was already positioned at this spot. So what I'm going to do, first of all, with your program launched, you can see there's a this one is called a daddybot. You can see the virtual robot. You can being listed here. What you can do is click here to get it connected. Everything's virtual, but this is a real EVC program apparently app. But the robot's virtual, the mat is virtual, everything else is virtual. So what you can do is just simply just run the program. Let's see how it works. You can actually see how the program runs here, which step it reaches. After turning, then it's come to here. And what you can do is you can rotate and zoom in to see how the robot works on the mat, to see is there anything not working as expected. Again, it is a very simple two-step line following algorithm. There's much better ways to do the line following. This is only for demo purpose. Here, when you see the robot purposely went over the line and hit that structure, you can see it actually interact with that structure. The beams got knocked down. Yeah, you can do the same thing with the swing and other attachment as well. We did not go too far last year because the idea is to try that to see how everything works. But with the team I was coaching, apparently the real set, the real robot, the mat is more attractive, appealing to my team members. So they spend most of their time on the real things, not this one. But I did spend a bit of time to understand how this works and show it to the team as an option in case anyone was interested to give it a try. This robot actually never got built. It is really created just for the purpose of trying VRT and trying Lego Digital Designer. I think that's pretty much it. I think it covers everything we need to cover. Thanks a lot for being with us, and see you next time. Bye.
Thank you so much, Yannick. That is amazing. You are very talented, and thank you for showing us so many of the advanced features of the Virtual Robotics Toolkit, and also talking about how the toolkit can be used to help enhance the experience for teams participating in First LEGO League Challenge. Just before we go, I'd like to mention some of the resources that are available. If you're interested in some curriculum-based lessons that make use of the Virtual Robotics Toolkit and that align with expectations in the math and science Ontario curricula, you can check out the VRT learning activities in the first resource. There's a YouTube sensation named Builder Dude 35 who taught me everything I need to know about Virtual Robotics Toolkit, and you can check out his tutorial videos at the second resource. Cogmation, of course, the organization that has developed the Virtual Robotics Toolkit, has a series of very useful video tutorials as well, along with a user guide. And a little bit earlier, I mentioned the STEM Hero course, and that's the link that you can visit to access the course as well. And this slideshow will also be available on the Kickoff Conference website. And so you can access this slideshow and click on these hyperlinks directly if you don't want to, type them down and write them down and then have to type them into your web browser. And so with that, I would like to, again, thank you for attending today, and also to thank Yannick for teaching us so much about the Virtual Robotics Toolkit. And if you'd like to contact either of us, you can do so at the email addresses provided here. I hope everybody enjoys using this tool, and please let us know how it goes. Have a great night, everyone.